Understanding the basics. What is unit testing? Unit testing is a software testing method. It involves testing individual units of code. These units are the smallest parts of your software. This ensures that each part works correctly on its own. Imagine testing the wheels of a car before assembling the entire vehicle. This ensures that the wheels are in perfect condition before the car is built. Think of building a house. You wouldn't wait until the entire structure is complete before checking if the walls are strong, right? Similarly, in software development we test individual components before integrating them. This helps us catch and fix errors early on. Unit testing involves testing these small units in isolation. This ensures that any observed behavior is solely due to the unit itself and not external factors. By testing units in isolation, we create a controlled environment that allows for precise identification of issues. Breaking it down. What is a unit in software? In software, a unit is the smallest testable part of an application. Think of it as a single function or method. For instance, a function that calculates the sum of two numbers is a unit. We test this function independently to ensure it returns the correct sum. Let's consider a simple example. Imagine you have a function that calculates the area of a rectangle. This function takes two inputs, the length and width of the rectangle. The unit test for this function would involve providing different combinations of length and width, and verifying that the function returns the correct area. Testing in isolation means testing a unit without its dependencies on other parts of the code. This is crucial to pinpoint the exact location of any errors. If a unit test fails, we know that the error lies within that specific unit, making debugging significantly easier. The power of isolation. Testing units independently. Isolated testing is crucial in unit testing. It ensures that we are testing only the intended unit. External factors or dependencies are removed or simulated. This helps to pinpoint errors quickly and efficiently. Imagine testing a unit that relies on a database connection. Instead of connecting to the actual database, we can use a mock database. This mock database simulates the behavior of the real one. This isolation ensures that any errors detected are solely due to the unit's code. By isolating units, we gain a clear understanding of how each part functions independently. This isolation is key to creating robust and reliable software. When units are tested in isolation, we can be confident that they will function correctly when integrated into the larger system. Reaping the rewards, benefits of unit testing and best practices. Unit testing offers a plethora of benefits. Early bug detection is a major advantage. It leads to higher quality code and easier debugging. It makes your code more adaptable to changes. Moreover, it acts as documentation for your code. To make the most of unit testing, follow these best practices. Test one thing at a time. Each unit test should focus on a single aspect of the unit's functionality. Use clear and descriptive test names. Test names should clearly indicate the purpose of the test. Keep tests independent. Tests should not depend on each other. Automate your tests. Use testing frameworks to automate the execution of your tests. There are various tools available for unit testing such as Junit for Java and PyTest for Python. These tools offer frameworks and utilities to write and run tests effectively. By adopting unit testing, you can enhance your development process and produce more reliable and maintainable software.